Okay, so let's go over one more time. Circumcenters. Circumcenters are when you have the circle goes through each vertex of the triangle. Okay? So you're just making a circle where the vertex of the triangle lies on the circle. And the center of the circle will be inside that triangle if the triangle is acute, like in this red triangle. See how that center is acute. With a right triangle, it's going to be on the hypotenuse. Always. And it always cuts the hypotenuse in half. Okay? So with the right triangle, this becomes what's called the midpoint. Because the whole purpose of finding the circumcenter is finding the perpendicular bisectors. Okay? That's how you find the circumcenter. Okay? And then when you have this blue one, or an obtuse triangle, your center is outside of the triangle. Okay? With that said, we're going to talk about this circumcenter so that we can figure out this diagram so that we can do problems 12, which is find the length of CF, 13, which is find the length of YC, 14, which is find the length of DB, and 15, which is find the length of AY. Alright. So we have to know some things about this. The first thing I know is that we have perpendicular bisectors. It says right here, DY, EY, FY are perpendicular bisectors. So what that means is, in our two-column proof, right, we're going to say that EY, DY, and FY are perpendicular bisectors. What that means, and that's given, okay? So what that means is what? That means that this is congruent to this. So our first step is that AD is congruent to BD. What else do we know? We know that AF is congruent to FC. So AF is congruent to FC. What else do we know? We know that CE is congruent to BE. CE is congruent to BE. Okay? So we know all of those things right now. Which is nice. Okay. So that means this is 59.7. This is 62.8. We know that much, right? Right there, right? So does that answer any of our questions? Are we looking for CF? Cool. So we know, why do we know this, by the way? What's step 2? Why do we know that? How do we get that? How do we know that those are equal? What's this called? Perpendicular bisector, right? The definition of being a perpendicular bisector is that it cuts it in half. Exactly half, right? So if it cuts it in half and exactly half, they have to be the same. By definition, right? By definition of being a perpendicular bisector, these have to be equal. With that known, then that means that CF and, well, geez, if I know that AF, right, is equal to what? 59.7, right, given? Then what do I know? That 59.7 is equal to FC, right? I just substitute it in. So we know that by substitution. That's easy. So we know this is 59.7. Do we need to know dB? Yeah, for number 14, right? So why don't we just do the same thing we just did? How much is AD?
62.8.
So AD is 62.8. So then, and that's given. Right? So by substitution, I should be able to find that AD, that 62.8 is equal to BD, right? Or dB, which is this. So 62.8. And I have my proof. Right? Okay? What else do I need? Or what else can I find? So YC and AY, what are those? YC goes from here to here. AY goes from here to here. Well, those are super easy. Super easy. Way too easy. But you have to know the rule, right? What's the whole point of a circumcenter? It's a circle, right? What's the coolest thing about a circle and its center? Think about it. The radius. Right? They're all the same. All radii are the same. Correct? If we look right here, we know that the radius from the vertex to the center is always the same. Right? So all we need to know is, do we know the radius of this circle? Now you can't see the circle, but you should know that it goes through all those points, right? And remember, the center of the circle is the perpendicular bisector intersections, right? So if we look at the perpendicular bisectors, we see that they intersect right there. So that's the center of the circle. That's the circumcenter by definition, right? So if that's the circumcenter, right? What point is that? Y? So 7. Y is the circumcenter, okay, by definition of a circumcenter. Okay? Because it's where the perpendicular bisectors intersect, right? So by definition, that's the center. And because that's the center, then Y to B is going to be congruent, right, to Y to C, right? Which is going to be congruent from Y to A, right? Because that's the